almost the same, but it is much simpler when dealing with proportion because you don't need to worry about the condition of your sigma and the condition of your number of sample. Now, for hypothesis testing for proportion, okay, almost the same. We have three types of tests: two tail tests, one tail test, whether it would be left tail test or right tail test, and also we will have the rejection region. And as usual, if the rejection region, okay, so if you are dealing with right tail test and this is your alpha, the rejection region, okay, so if you get your Z test statistic is inside what we call inside your rejection region, then we reject. So this is your Z test. So in this case, we reject null hypothesis. What if it is inside the non-rejection region? So if this is your Z test, okay, then we fail to reject null hypothesis. Okay. So for those who just joined the class, please fill in the attendance. So later on, if I feel it is necessary for me to bus the students who did not attend the class, so I will just do that. Okay, since the attendance getting less in terms of number of students. So now, what difference between the population mean and population proportion is the test statistic, because the test statistic is based on the proportion. And how can we calculate the test statistic for the proportion population? Okay, so we will have the sample proportion minus by the hypothesized population value, and then divided by the hypothesized population value as what we have in the denominator. Okay, so how do we get our p-hat? P-hat is obtained by dividing x with the sample size. What is x? X will be defined in terms of the number of sample involved in the specified what we call event of x. Okay, so that would be more or less on the fundamental for the population proportion. Now let's look at the equation, so it will be much clearer. Okay, so when working properly, so if you look at your example on page 91, okay, when working properly, a machine used to make transistor produce 4% defective transistors. Whenever the machine produces more than 4 defective transistors, the machine needs adjustment. So means that if defective, okay, if defective is more than 4%, then require adjustment. Okay, and then what? The quality control department takes a sample of 200. Then we know N is 200, and inspect either good or defective to check. And inspect either good or defective to check whether the machine is working properly. It is found that 14 from 200 transistors, so in this case our X is equal to 14. So that is defined by X, the number of defective transistors. Okay. Now, test at alpha 0.05, that is 5% significant level, whether or not the machine needs adjustment. Okay, so remember, you need to figure out which one is your claim. You need to figure out which of the statement become your what we call null and alternative statement. So before we can do that, first find what will be your p-hat. So in this case, p-hat is equal to x divided by n, which is 14 over 200. Given by, so 14 over 200, so you will get 0.07. Okay, so first, okay, let me use my blue pen. Okay, now an alternative. So in this case, okay, so in this case, we know that the simplest one will be P is equal to 4%, which is 0.04. Now, what would be my alternative? And how do I figure out? Okay, so it is said that test at 5% significant level whether or not the machine need adjustment. If needs adjustment means that if it is reflecting to this particular statement. So P is greater than 0.04. Okay, so in this case, this automatically become your trim. Okay, so this will be your trim. Now, second, okay, so if you are using your traditional method, so we need to find the critical value Z alpha. Since this is a one-tail test, so we are dealing with one-tail test, so Z 0.05 is given by, is it 1.6449 plus? Is it correct? Even though I refer to the same exact table, I always forgot. 0.05. Okay, 0.05 is 1.6449. Okay, 1.6449. So I know then this is my critical value. Third, my what we call test statistic. So test statistics obtained by Z, and that will be our P hat 0.07 minus your P naught, that will be 0.04 divided by square root of P hat, that will be P naught, that will be 0.07 multiply with 1 minus 0.07, that will be 0.93 divided by 6, 0.04, sorry. Okay. 0.04 P naught. We are using the P naught. So 0.96 divided by the number of samples, 200. So you will get 2.165. 2.165. Then, okay, you will get your division. Okay. So my alpha is 0.05. My Z alpha is 1.6449 and my Z test is 2.165. Okay, 2.165, for example, let's say this is where 2.165 are located. So falls in the rejection region. So since Z alpha, or right directly, Z 0.05, okay, is smaller than Z test, okay, 1.6449 and 2.165, then reject the null hypothesis. Okay, reject the null hypothesis. Okay, then by making conclusion, okay, our claim is at the alternative, and yet we reject the null hypothesis. Therefore, we have sufficient evidence. Okay, therefore, we have sufficient evidence to support our claim that, okay, the population proportion, okay, that the population proportion, okay, that the population proportion of defective transistors of defective transistors okay, is more than 4%. Okay, at 5% significant level. Okay, so usually we will ask, okay, what would be the action by the company resulting from the hypothesis test? Then you will answer the machine need an adjustment. So that would be your answer if you are being asked that. So that's how we are doing the what we call using the traditional method for the hypothesis testing of the population of proportion. Okay. Now let us look at the exercise. Okay. Look at the exercise. Number 1 is about the detergent. Number 2 is about the pharmacy company. Okay, let's see, we try number 2. Any questions so far, class? Before we begin with the second question of the exercise?
No, doctor.
Any question? No, right? Okay. A pharmacy company claims that less than 5% patients who use a new brand of drug will experience a side effect. To support the claim, 2,000 patients will subscribe with the drug and only 75 experience side effects. Okay, so let us take out the information from the patient. Now we know that the claim is this one. A pharmacist company claims that less than 5%. So we know that the hypothesized proportion is equal to 0.05. Okay, the N is 2,000. Out of 2,000 patients, okay, only 75 experience the side effect. So X is equal to 75. Then we know that P hat is obtained by 75 divided by 2,000. And you will get 0.0375. Okay, so that would be your P hat. Now, let us look at question number 1. Determine whether the company claims can be supported at 5% significant level. Use p-value method as additional exercise. Okay, so let's begin with the hypothesis procedure. So the first one, okay, first step is the statement. The statement of null. So P is equal to 0.05. Alternative, P less than. So less than 0.05, which is the claim of the test. Okay. Second, p-value method, then we need to find the z-test. So z-test is equal to p hat 0.0375 minus p naught. Okay, so that would be 0.05 divided by square root of p naught. Okay, so p naught 0.05 multiply with 1 minus p naught, so that would be 0.95 divided by the number of samples, 2,000. Okay, so can someone calculate? We just recheck. 0.0375 minus 0.05 divided by square root 0.05 divided by 2,000. Can someone confirm? Is it correct? Negative 2.565. Okay, anybody?
Yes, doctor.
Okay, thank you. Number 3, find the p-value. So p-value. Okay, so p-value, we know that we are using the z-test. Okay, so the z-tail test So the left tail test is, that test is negative 2.565. This is the p-value that we need to find. Okay, this is the p-value. Okay, so this is the p-value. So okay, so this is the p-value that we are looking for. Okay, now since we need to use the first table, so we are using the right hand side. Okay, let's say this is 2.565. Okay, so we need to find what is this p-value, sorry, this area. So z between 0 until 2.565. Okay, so 2.565, look from your z table, the first z table, 2.565 then 2.565 or 65, 2.565, 656, 2.56, 2.56, 2.57, 2.5, 2.57, 257, 2.57, 0.4949, 0.4949. Okay, so here is 0.4949. So p value is equal to 0.5 minus 0.4949 is 0. Minus 0.5 0051. Right? Okay, so your p value is 0.0051. Okay, so and your alpha, so making division, the division alpha is equal to 0.5%. Okay, 0.05, and your p value is equal to 0.0051. It seems that alpha is larger than the p-value. You can imagine the p-value is located in the rejection region. So if I can redraw using the red pen, where is my alpha? So my alpha is larger, so it should be larger. So because my drawing is not really correct in terms of the value, so we know that this is our alpha. So this is our alpha, means that our p-value is inside the rejection region. So we will say reject null hypothesis. Okay, so reject the null hypothesis. Okay, reject the null, so means that we can make conclusions. Our claim is at the alternative, and yet we reject the null hypothesis, then we have sufficient evidence to support our claim. Okay, so therefore, we have sufficient evidence to support our claim that that the claim less than 5%. So less than sufficient evidence to support our claim that less than, sorry, less than 5%, okay, 5% patient who use new brand of drug, okay, will experience side effect. Okay, so that would be the conclusion for the first question. Without any calculation, if we choose a 1% significant level, now we expand the question. Just now, we are talking about significant level of 5%. Now, if let's say, without any calculation, if we choose a 1% significant level, can we reject the null hypothesis? Why or why not? And now we are talking about alpha is equal to 0.01, right? 0.01, right? Okay, 0.01. Now, our p-value, okay, we know that our p-value is 0.0051, okay, which is still smaller than your alpha. Okay, so we know that in this condition, we still reject the null hypothesis. Okay, so in this case, how can you answer? Without any calculation, can we reject? No. Yes, sorry. Yes, we can reject. Okay, yes. Why? Because alpha is larger than p-value. That's it. Okay, so that will be how you can answer for the second question. Okay, now if I ask you, at what level of significance, we will not be able to reject the null hypothesis. How can you find what will be the alpha value? At what significant level we fail to reject the null hypothesis? That would be my question before we stop class.
0.5%.
Fail to reject. Fail to reject.
0.05%.
Yes, at 0.05 significant level, or at least 0.051 at the same value as your p-value. Okay, so we will not be able to reject the null hypothesis. Okay, so if you say at 0.51%, okay, 0.51%. If you say percent just now, I'm sorry, I didn't hear the percentage now. That will be correct. Okay, at least the alpha level will be equal to your p-value, so that we will not be able to reject the null hypothesis. Okay, so that will be the last point for our lesson tonight. Okay, so I wish to continue with the nearly to conclusion, but I think I'll just leave this before we can discuss on the two population for statistical inference, two population, means and proportion. So this one would be your conclusion. So I'll just keep this for the tomorrow's class. Okay, so stop sharing.